He left.
Hello, testing, testing. Can people even hear me? I think people can. OBS lights are going up and down. That should be a good sign. Hello, hello. I'm here. Let me get my Chrome window up. Where did Chrome go? Oh, there you are, Chrome. There we go. Okay. Hello. We are trying the try problem again from last time. Last time we attempted it in a way that I thought would work, but it didn't work. See, I attempted this problem. I think I said last time that I would just count it as solved because it basically works, except for one test case, or maybe it was a lot of test cases, I forgot. But anyways, I want to try the proper way of doing this problem today. Yeah, having seen the solutions already, hopefully it's possible. Hi Krishna, hello. How are you doing? Okay, Leetcode 1268. Search suggestion system. You are given an array of strings, products, and a search word. Design a system that suggests at most 3 product names from products after each character of search word is typed. Suggested products should have common prefix with search word. If there are more than 3 products with a common prefix, return the 3 lexicographically minimum products. Return a list of lists of the selected products after each character of search word is typed. Ooh, I see. Bruzilla says, yeehaw. Yeehaw, partner. Okay, so let me get on my pen over here. So for example, in this problem, you're given a list of products like this, and then you're given a search word, which is this thing. So you're supposed to simulate the search word being typed letter by letter. And then you're supposed to, for each additional word that they type from the search word, for example, they would be typing mouse over here, you would output 3 search suggestions, kind of like if you're typing into the search bar of Google. So apparently if they type mouse, you would return mobile, money pot, and monitor, because that's the 3 words with prefixes M that are first alphabetically sorted, I guess. Bruzilla says, think mate forgot me. Bruzilla, not gonna lie, I think I did. Your name sounds familiar though. Yeah, it's not coming back. What interactions did we have? Which stream? And if they type MO, we would return mobile, money pot, monitor. Panyan, oh, you're the guy who showed me your website. The green website, the medical doctor guy. Oh, I remember. I just didn't remember the name. Hello, how you doing? What's the progress like on your, I think you were scanning retinas to identify diseases? How's that going? Okay, so last time we tried a thing where, let's say this is like our trie, right? A trie is basically a tree of characters that lets you efficiently store a bunch of strings with same prefixes. What we did last time was we stored a trie, right? A trie is the right way to go. So if you're inputting mobile, M, O, B, I, L, and then E. And then let's say you're inputting mouse, M-O, you would branch out over here into U, M-O-U, S, and then E over here. Yeah. So I think what we did last time was we, at every single node, we would store a list of all of the words that pass through this node. So like we would have like mobile here and then mouse over here. For some reason that doesn't work and I don't know why. But apparently what you're supposed to do, is not do that. Bruzilla says, I am a duck. I have the framework set by Yap BT. Don't know where to start. You are a duck, like a sitting duck. Don't know what to learn. You have the framework set by Yap GPT. don't know where to start. You mean your whole retina detection thing? Detecting diseases by retina? You're trying to code that from scratch? Like, what are you trying to code with Yap GPT? Manoj says, hi. Hello. Hi, Manoj. Okay, so apparently what you're supposed to do is, instead of storing every single word in every node that passes through the node, what you're supposed to do is just store where the words end. So mobile ends here. So you would store some sort of variable that stores the end of the word mobile. I just realized something really crazy right now. M-O-U-S-E. So you would store the end of it. Maybe it's like a boolean in the node. We would store boolean word equals true or false. And then let's say we even store the word mouses. Mouses like that. If mouses is a word that we've searched before, then we can mark it as the end of a word. I'm so much more fluent today. I think it's because I've just been sleeping my butt off the past 2 days. I just realized how sleep deprived I was the past week. This is good. ChatGPT, Yap GPT. The coding part, the feasibility thingy. Wait, what feasibility thingy? I just remember you're trying to detect diseases through retina. Is that what you're trying to code? Or are you trying to make another part of your website? Okay, so I think what we're supposed to do is every time we type a new word, let's say that the user types the word mouse, right? So they would type M first. We would look at this node. And then what we would do is, I think they call it in-order traversal, which is for every node, look at its children and traverse the children in alphabetical order, basically. So M is here, O, that's the only children, so traverse here. Then you get to B and U. B is the first one alphabetically, so you would go to this one first, and then down, 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 until you see a word over here. And then you'd be like, oh, I have a word. And then you would sort it in put in your list of words. And then you would go back up because you're done. And then you would traverse U, S-E, oh, that's a word. Put into your list. S, oh, that's a word. Oh, I have 3 words now. Okay, let's return this list because this is the best. Yeah, that's the algorithm. And you would do this for every single word that they type. O would be the same. U, you would traverse down this line. Bruzilla says, generally, I'm sorry. Oh, don't say that. I feel like I'm interrupting you so much while you learn to Leetcode. No, don't say that. Wait, I asked you a question, like, what are you trying to code? The actual product of the disease detection through retinas, or like more of a website? Okay, so I think we need a class, additional class called Trie or something. We probably need some sort of function to input every single product into here. And then we need a way to traverse all the nodes as the person types the thing out. I think. Maybe we should have start up a try class, a method called add to try. We probably need a subclass called like try node, or just node, that stores the value, and then a boolean that's the end of a word. How should we handle every single character that they type? Should we store the current node? That's probably a good idea, right? The current node. And then for every single node, do a DFS. I think that's possible. Minaj says, can you suggest me best way to learn graph algorithm? Oh, graph algorithm. There's lots of graph algorithms. Maybe start with the basics like DFS, BFS, depth first search, and then breadth first search. Those are the two most common types of graph traversals. I think YouTube videos are a good way to start. Maybe just look up like YouTube videos of graph traversal, like Leetcode graph algorithms. Definitely start with BFS and DFS. Maybe try the most common graph Leetcode questions next, like the ones on Leetcode or the ones on the blind 75 list. That'll teach you how to use more graph stuff, and then if more concepts pop up, you can look into them too. There's a thing called Jensen's chart. I am keeping that variable to learn my ML model to spit out answers is first thing. Jensen's chart? Jensen's chart. Jensen's chart. What cheats to follow, or should I do Leetcode by topics? I want to learn in details, maybe reading books. Oh, speaking of books, the first book I ever read for preparing to Leetcode was Cracking the Coding Interview. This one. This was a book I read. I thought it was pretty good. Yeah, it is in Java though, but it does break up Leetcode concepts into like different subjects, and then yeah, I think the way it clusters the questions is really nice. I believe there's a graph section that, and it is like a 2-3 pager that tells you most of the concepts you need to know about graphs. So I think I like this book. And in that variable, each variable will have a different characteristic like depth type and so, which means Cripps Lucene types of characteristics for more better answers that ML spits out. I have no clue what that means. What's like the, for someone who doesn't know medical stuff, what are you trying to make? An ML model that does what? Should we start off with a try? It's time to try. Okay, class, try, and in the class we'll have a try node that has an init function, define init function that will take in a value, and then it has some instance variables for when you instantiate into objects. Self.value is equal to the value. It will have children, self.children is equal to empty dictionary, I suppose. The keys will be the characters, and then the values will be the node that they correspond to. See the Jensen's chart, that the pictorial representation of divisions of iris. Oh, this is an iris, right? Oh, I am a human. How do I make this bigger? Open image in tab. This is so blurry. Not useful. Yeah, what about this? I am also using Java for DSA, but books have around 600 pages. Can I go directly to the graph section, or should I start from the beginning? You can start directly from the graph section. I don't think that's a problem. That's a brain. What? There's a face in my iris? What? Lungs too? Okay, and then something different that we'll do this time is self.boolean, I guess, is word. If a word ends here, it's equal to be false by default. Yeah, okay. Is this how you instantiate? I always forget how you instantiate inner classes in Python. Python inner class. I swear I've looked this up like 2 times already. Outer class, inner class, okay. Self.inner class, so that's how you use it, I guess. Self.inner class. Sure. Okay, so the init of the trie, the init function of the trie, self. I should probably do a self here too. They all need that. Self. We need to initialize probably the root. Self.root is equal to node root. Okay. Okay, suggested products. Let's just try building our trie first to see if the initializers work at all. So my trie is equal to trie, and then let's just return a bogus value so far. And let's just see if this even compiles. Let's go. Expected a colon where? Class trie. Oh, class trie. Well, this was a good decision. Nice, it compiles, okay. Cool. Trie.root.value. Can I try printing this out? Did we instantiate our root correctly? So when a patient has a lesion or those characteristics that we doctors see, we come to a part of possible diagnosis, stating this can be that, so I want to make my ML learn this. Oh, okay. What's a lesion or those characteristics that we doctors see? So basically you want to train an ML model to look at pictures of irises. Is that it? Trie.root. Really? No variable root? Self.root. Yep, exactly. Oh. Dang, that sounds like a tall order. That sounds really difficult. How are you going to do this? I'm not an expert in ML, by the way, so just because I am in disbelief doesn't mean it's not possible, by the way. Trie.root. So I cannot access the root, self.root. Display outer. Self.root is equal to node root. Trie object has no attribute root. We did a self.root over here though. Trie dict. I heard this was a way to see all the keys in the object. Is not callable. Okay. Self.root is equal to node root. So why can we not? Hold on. I'm gonna ask my best friend ChatGPT. Trie.root. Do I just not know how yeah, okay. How do I access instance variables in Python? Why can I not access the self.root in the trie object. The init function. Self.root is equal to node root should be written as self.root is equal to trie.node. What? To explicitly reference the node class inside trie. This is the error message. Oh, wait. I have to include in itself. Oh. Dang. How could I have been so blind? Node is not defined. Trie.node. Wow, that's it? In this current technology, can we be able to do this? I assume we developed quantum computers, duh. Eventually I think I'll figure it out. Alright, good luck on that. I have no experience with machine learning either, so very little. Maybe you can ChatGPT like what ML method would be the best for this. Cool, so I guess my mistake was I needed to do trie.node to access the inner function. What? You lied to me. Self.innerClass. Oh, Google was telling me that all along. Self.node. Dang, so that's how it works. Okay. Maybe I should write this down. This seems like a huge blind spot for me. Where's my Python page in my notebook? Oh, here it is. Okay, so classes. You can't tell, but I'm writing in my notebook right now. Classes, inner classes, class, outer class, and then you have a class, inner class, and then you would do a x is equal to self.inner class. Yeah, so I'm missing the self part. Okay, I will remember that now. Cool. So now we need a method of actually inserting the words into the trie. So define add to trie self and the actual word. Okay, so the current node is equal to, let's set it to self.root, and then for every single character in the word. Okay, so now we have to look at every child in the current root, the current node, and be like, okay, does the node for this character exist in the current node? If it doesn't, we have to make it. And then we set the current node to that character, and then we keep going for every character. Yeah, that should be it for now. And then at the end, we should set the last node that we're on. We should set isWord to true. Yeah, that should be how it's done. enough yapping about me. Let's talk about Leetcode. I'll be you, nerdy buddy. Thanks. For C in words, so if C is not in the current node dot children as a key, then we have to make a new node for that character. So we do node dot children with key current character is equal to new self dot node, where the value is equal to the current character. And now we can safely set current node equal to the current node dot children C. C, senor. And then at the end, we set the last node dot is word equal to true to mark it as the end of a word. So self node dot is word is equal to true. Okay, we can do a really simple test to test this out. So we can do try dot add to try, and we can add mobile, just the word mobile like an example. And then we can do root dot children m dot value. Make sure there's an m in there, and then an m, make sure there's an o in there. Dot children o dot value. Okay, let's test this out. Did I forget the colon again? Colon. Ooh, MO, let's go. Okay, I think we are adding the words correctly then. Nice, okay. What if we just do mob children O dot children B dot is word, so this should be true. So we should get mo true. Mo true. Nice, okay. So we are correctly instantiating our try now. Very good. So what we can do right now is for every single product in products, we can insert every single product into the try. So try dot add to try the current product. Cool. That is our try. Now we have to process every single character of the search word. I'm thinking we track the current node. Yeah, the current node. And then for every C, we do a DFS. So we'll have to code a function to do a DFS. Or not DFS, like in order traversal of the tree to try to find the first 3 words that are closest to it alphabetically. Okay, so we'll do a node is equal to try dot root, and then we'll do for every single C in search word. We will have to first get to the word. So node is equal to the current node dot children C. If C is in node dot children, else just none, I guess, if it doesn't exist. Okay, and then for every single new character, we will have to come up with the 3 words closest to it, to the current prefix, and then put it into a results list. So we can probably have a 2D array called results is equal to that. And then we can have a helper function called, well, we can do results dot append, maybe get 3, what should we call this? Get 3 best. Get 3 suggestions. I guess this will be a function that try dot get top 3 results using what should we pass into this function? We should pass in, we already have our try. It's 1:25 in here. I'll have my lunch and join ya. Oh, enjoy your lunch, man. What should we pass into this function? Should we pass in the entire search word? Ooh, okay. I'm trying to think about the logistics for this, because if we just straight up pass in the node, and then the entire search word. So let's say we have mobile, right? And we're at B. So we would pass in the node for B, and then the search word would be mobile. That's kind of confusing, right? We'll have to like chop off the first few characters until we get to the B. Should I just pass the entire prefix in? Iterating down shouldn't be too bad, right? We're going to be iterating down nodes anyway, so it's still going to be like log n time in terms of traversing. Well, yeah, we're going to do like n time for traverse, worst case n time for traversing and trying to find the top 3 words, isn't it? So going down the nodes to try to match the prefix shouldn't be too bad every time. So there's no need to track the current node anymore here. There's no need to track the node here. What we have to do is track the current prefix. So prefix is equal to just an empty string for now. For every CN word, prefix plus equals C. And then every time we have a new prefix, results.append try.get top 3 results, the prefix. Yeah, that makes sense to me. And then in the end, we will return results. Yeah. And then up here, we will have to implement a define get top 3 results with the following prefix. Don't forget the self too. You cannot forget about yourself. Let's just return a empty list for now. And then let's just make sure our code even compiles at this point. Cool. So we're returning 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, cool. Our stuff is working. So now if we get top 3 results, we will have to perhaps iterate downwards. Wait, hold on. I'm having some second thoughts. Is this the best decision to just iterate down to our prefix every time, can we not store the actual node and then DFS from there? Well, yeah, we could do that, right? What am I doing? We could store a current node and save ourselves a bunch of time without it being too confusing. We can store, like, the current node is equal to trie.root, and then for every single C in search word, get the child that corresponds to it. So node is equal to node.children, get the C, right? Node.children get the C. If C is in node.children, else return none. And then all we have to do is pass in the current node here. Yeah, and then DFS from here. Yeah, we don't even have to worry about the rest of the word here, right? We just DFS from here, get the top 3 words in order traversal from here. Ah, okay. So get top 3 result is just a pure DFS. Nice. Okay, okay. Let's first make sure this even runs. Cool, okay. Let's print node.value mouse. Perfect. Okay. All right. So now the hard part. So now we have to perform a DFS in order traversal while tracking the top 3 words. Wait, hold on. We might actually need the prefix in this traversal because we only, let's say we're at B, right? We don't know MO, the last thing. Oh wait, we might need the prefix, oh no. Because all we know is B right now. Alright, we need the prefix. Prefix is equal to empty string. We'll update the prefix every time. Prefix plus equals C, and then we'll have to pass in C, the current node, and the current prefix. Node prefix. Cool, okay. Should we take care of some base cases here? Okay, I'm kinda... How do we store... How should we store the top 3? Should we store it in a list? How do we pass the list throughout? Should this be in a outer function that we keep updating? I think it should be, right? I don't want to keep passing it into into the function signature. That would be kind of messy. Okay. So some base cases here. If none, if the node is equal to is none, then you return empty. Else result is equal to, we already have a results, right? Top 3 results is equal to an empty list of strings, and then we'll call some sort of DFS on the current node. Okay. Storing the current prefix, and then we can accumulate the prefix as needed. Sorry, not DFS. In order traversal. In order traversal with the current node and prefix. Okay, so now time to code the in order traversal. Define in order traversal. Pass in the self. We have the node, we have the prefix. Basically the current word. Should I have to do a self here? Self dot in order traversal. Can we just do a prefix print first? Cool, okay. Looks like we're calling the function correctly. Okay, time for the in order traversal. Ooh, how do we do this? So if the current, we have to do the work at the current node first, right? And then we'll probably have to sort the keys in some sort of alphabetical order somehow, access them in alphabetical order, and then for each, yeah, basically for every key A to Z, traverse it, right? So if, let's do the base case, if the current node dot is word, then top 3 results Wait, can you do this? Can you access top 3 results from here? Python. This can only happen in inner functions, right? Inner functions. Use outer variable. Yeah, I think the classes can only be embedded in each other for this to happen. So like that. In order traversal, self, node, prefix. So top 3 results dot append the current prefix. Do I have to add the current? Oh, I have to add the current character of the node into prefix. Prefix plus equals node dot value. Or have we already done this? Have we already done this here? Yeah, we should have already done it in the first place, right? If we're at MOB, the node will be B and the prefix will be MOB. So this shouldn't be here. If the current node is a word, then results top and prefix, okay, fine. And then else we need to traverse in order, huh? How do you traverse letters A to Z in Python? Python, how to traverse A to Z. For character and string ASCII lowercase? Really? I've never seen this before. Can I get a Python interpreter here? Python online interpreter. Print this is a thing. Spider-Man says, hey, I'm back again. Hello. Hi, Spider-Man. String is not defined. Import string, string to ASCII lowercase. You know, worst case, I can just literally do like A, B, C, D, F, G, you know? Is there really no way to iterate letters A through Z without importing something? For I in range, word A. Yeah, can you plus plus a character? Okay, people are recommending this one, ASCII lowercase. String dot ASCII lowercase. Okay, for every character in string dot ASCII lowercase, print C. Let's just do that for now. Does it actually work? Self.iot. It's right here. Trie object has no attribute. Oh, do I not need the self here? There we go. Dang, it worked. A, B, C, D, F, G. Okay, sick. Okay, so you only need the self if the function is like a instance function, huh? Okay, so if C in, we're saying for every character in from A through Z, if C is in the current node dot children, then you iterate on it, and you have to update the prefix to prefix plus equals C, and then you do in-order traversal, the current node, the new node, node.children C with the new prefix. We should use another prefix, shouldn't we? We shouldn't update the current prefix. We should just literally do prefix plus C. Yeah. Right? This is pretty clean. So in this way, we don't destroy our original prefix thing. Yeah, and then if top 3 results, the length of this is equal to 3, is greater than or equal to 3, then you return top 3 results, or just return, I guess. Actually, do we need to do the line 3 check here too? Would it keep iterating from A to Z without stopping? Maybe we can do a if length of top 3. Oh yeah, here. We can do at the top. So if we try iterating through any character, like if we've already found 3 matches for the prefix, and we try iterating through the other characters, we just return immediately. Yeah, sounds good to me. Bam. If length top 3 results is greater than or equal to 3, then just return immediately. Else, if the current node is a word, then top 3 results append the prefix. For C in string ASCII characters, if C is in node children, in order traversal, recursively node.children C, the new node, and then prefix plus C. Okay, let's try running this. No, 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 please go. Why no? Get top 3 results. So you run the in-order traversal. Oh, we return nothing. So we return top 3 results then. Oh, we did it. At least these two examples. Do we have any print statements here that would mess us up in the runtime? I don't think so. Okay, let's submit. No! Use this test case. So it says none type object has no attribute children. Ah, okay. So we have Havana, Tatiana. Yeah, that makes sense. Okay. For C in search word. Wait, but C is not in node.children. Wait, wouldn't this catch it though? If C and node.children? Let's do print current C with C. The T would fail immediately, right? T. T and then A. Dang, it actually tries to get a T. It actually tries to get an A? Really? How does it get a T? Line 47 is here, right? Node is equal to trie.root. But no way. Is C actually a node.children? Print C and node.children. Children. And then let's just pronounce C and node.children. This is ridiculous. Why are we actually successfully getting a T? Oh, look. That's false immediately, right? Okay, that's good. And then node is equal to node.children C, else none, results.append trie.get top 3 results. Oh, it's here, node.children. It's this check over here, node.children. Should we literally do a... if node is not none, and that... So node is equal to node.children C if node is not... What am I typing? It's if node is not equal to none, and C and none.children else none. None type. Okay, so delete these print statements. Hey, we got it. Submit. Please, Leetcode gods. Ah, finally! We spent 2 days on this problem. We finally did the right way. Let's go! I feel like a genius. We've been here for an hour. This feels good. We definitely did it for some reason the wrong way last time. Now we actually did it, the proper way in order traversal. This is nice. I think I have to write certain things down. String.ascii lowercase. That's a convenient way to iterate from A to Z. Strings. Okay, how to iter characters A to Z. String dot ASCII lowercase. Cool, okay. I feel like I have to do this again sometime. I was really slow in this, but at least we got it. Cool. I don't know if I want to try another problem today. I wanted to try 692. Why did I write down 692? Leetcode 692. Maybe I can just preview this problem. Top K frequent words. Ooh. Given an array of strings, words, and integer K, return the K most frequent words. Wait, an array of strings, words, and an integer K, return the K most frequent words. Return the answer sorted by the frequency from highest to lowest. Sort the words with the same frequency by their lexicographical order. Ooh, interesting. This is a priority queue, isn't it? I love Leetcode, I love coding. K equals 2 equals I love. H-I-J-K-L. Yeah, L does come after I. This sounds like a priority queue, no? We have to... Ooh, wait, this is actually really interesting. How do priority queues work in Python? So we can insert each element like this by their count, the number like that, and then the actual word. So this way, we would sort them in lexicographical order. Oh, how do priority queues work in Python? I've never actually used a priority queue. Python priority queue heap queue model. Heap queue.heap push. Which one do people actually use? Queue.priority queue class. Priority queue in Python. They're actually telling us to implement it from scratch. Using a list, if you don't need to make many insertions. Should I just use heap queue? Maybe heap queue module. So then it's just a list over here, then heap queue.heap push. You input the list and the thing and the element to insert. I actually want to try this. If this problem is a priority queue thing, I think I can get it done relatively quickly. I hope I did not just jinx myself. Top K frequent words. So inserting this. What would the runtime of this be? I totally forgot priority queues. Insertion would be login time, right? So in login time, every word probably. A priority queue uses a tree-like structure under the hood, right? So it would be login time insertion for every single character. And then when we pop them, one time. Are we getting ELO this week? No condom, Chris. I've been losing ELO points the past 2 contests because, well, one is I keep arriving late because of new time zone now. I don't know if you're in America, but America does this stupid thing called daylight savings where we turn the clock forwards an hour and then backwards an hour at certain times of the year. So right now, Leetcode weekly contests are at a really inconvenient time for me. It's like 6:30 when I eat dinner, usually. So I usually have to skip dinner now to do the contest and then eat dinner. Yeah. Okay, let's do priority queue is equal to empty list. Apparently you can do heap queue.heap push. Heap queue. And then for every single word in words, you can do a little heap queue. Heap. Is it called heap? Heap queue.heap push. What does heap queue even stand for? Heap, keep queue, literally. Dot heap push. Heap push into the priority queue with, wait, hold on, sorted by the frequency from highest to lowest. Wait, you can't just do this, right? Oh wait, hold on. We can't just input them one by one. What if we have like the same words? Oh, hold on, I have to think this through actually. What if we... What if we sorted the words first and then... No, actually... What if we iterated left to right first and then just count up all the words in the dictionary? The key being the word, the value being the count of the word. Yeah? And then we input all the value comma key pairs into a priority queue. Yeah, that sounds like a plan. That will be end time first plus end log n time, so still end log n time. Okay, let's go. counts is equal to a new dictionary like this for every single word in words. Counts of the word is equal to counts.get or default is just get the word, or default is 0 plus 1. Sick. I think that's it. And then you print out counts. I'm going to comment this stuff out first. Did we do counts correctly? I is 2, love is 2, Leetcode is 1, coding is 1. Perfect. Okay. I is a genius. Cool. And then for every value comma key pair in counts, we would put into the priority queue. So the priority queue is just a list by itself. And then for every word comma count in counts.items. Let me first print this out to make sure I'm iterating through it correctly. Print the word comma count. I 2 love 2 Leetcode 1. Cool, we're doing it right. So heap q dot heap push into the list called pq. We will add in the tuple count comma word. This should sort it in alphabetical order, right? Let's just print out what our pq is. Pq one coding. Oh wait, this is backwards. How do we sort it in? Oh, hold on. How do we sort it in the opposite order? Maybe we can just times 1 to the count. Coding Leetcode. So this is alphabetical order forwards, the words. If we just do minus count, it should do the right thing, right? I love, oh, that's it. Top K frequent. We have heap push max now. No way, heap push max. You don't have to negative. Heap push underscore max. But is this gonna sort the words in descending order now too? Let me just try this. Print pq. Heap pop max. Wait. Heap pq heap push max. Huh. It was introduced in 3.14. They are using old Python. Oh, I see. I guess I'll have to resort to negative for now. That's fine. Get out of here. Okay, let's print this out. So now all we have to do is get the first K. Oh, max. Print the PQ again. 1 Mississippi, 2 Mississippi. Cool, so I love, that is the answer. Cool. Nice, okay. So now all we have to do is make a results list. Results is equal to an empty list for I in range. We should take the min of k and the length of the list, right? Of the PQ. Yeah. Results dot append counts. Wait, what am I doing? The priority queue at index I, and then we would return results. Oh wait, that's wrong, isn't it? I only have to return the word, not the invalid syntax. Oh. Return, and then at PQI, the word is the first index, so index 1. Oh wait, this is not alphabetical order. I switched sunny and is. The day is sunny. Oh, interesting. Is has 3 counts. Shall we print out what PQ is? Oh. Oi, what's up with this? Oh, does priority queue not guarantee order? Like, it only guarantees the first one is it only guarantees the first one is the least one, right? Oh, so I have to actually pop them. Heap queue dot heap pop. Yeah, that's it. Oh, interesting. Heap queue dot heap pop. And take the word from that tuple. PQ. There we go. Submit. I really have to write down how priority queues work. This is actually my first. Let's go. I need to write down. This is my first time using priority queues in Python. I'm gonna forget this so fast. So, Python priority queues. So it's called heap queue, huh? Interesting. Everything in Python. I think they want the quick select solution though. What's the quick select solution? Oh wait, there's a better solution? Let me write down the priority queue in my notes first. So everything is just a list in Python, huh? Heap queue dot heap push. And then heap queue dot heap pop the priority queue. Okay, so this is n log n time. You have to know the algorithm for quick select. Unlikely you can just reinvent it. Oh, okay. Well, in that case, I'll just read the solutions. Is this quick select? So you have, okay, count for W in words, count W is equal to, yeah, you make a dictionary with the words and their counts. Bucket I is equal to list of words. This is not it? Oh. Okay, time to pull up Leetcode Premium then. max heap, min heap. Which one is this? Quick select. Maybe I'll just Google what quick select is. Quick select algorithm. Oh my goodness. Is a selection algorithm to find the kth smallest element in an unordered list. Is this it? It doesn't sound like exactly what we need. Find the kth smallest element in an unordered list. Hold on, I have Leetcode Premium on another browser. Let me pull up my Microsoft Edge properties. Properties. Okay. So this is the solution for top k frequent words. Okay, brute force. Sort all the words by their frequencies, return the first k words. First by frequency and then lexicographically, okay. Max heap. What about Python? Whoa, this is so short. Wait, this is so interesting. You can just do counter words. I should probably learn this class. Counter. I've seen people use it during coding contests too. So heap is equal to minus frequency, comma word for a word, comma frequency, and count to items. Heapify heap. Wow. Return heap pop heap 1 for blank in range k. So this is n plus k log n time, where n is amount of words, I guess, and then k is what? Oh, k is number of words you want to return, okay? N plus k log n time, okay? This is n log k. Bucket sorting plus trie. This is O of n time? How did they get O of n time? Is this the way? With a trie? Oh my goodness. We have to turn to non-comparison sorting. You can sort with n time? For the words with the same frequency, we store them together in a trie. Oh my goodness. By traversing a trie in pre-ordered DFS way, we can get all words in a trie in a lexicographical order. Toby says, hello, I remember you from like ages ago. Hello, Toby. How's it going, Toby? I don't remember you. I do have a vague memory of the username though, maybe. My memory is super bad though. If AB and AC, okay. Huh. No condom, Chris, you banned me ages ago. Huh. So if AB and AC only occur once, but ED occurs 3 times. We build the following buckets and tries: root, AB, and AC. I came in at the end of one stream and trash talked your code. Oh. Oh. I remember that. Well, hey Toby, hello. Yeah, I think I remember that. That's pretty funny. At least to me. Okay, so we basically build a trie for for all words of the same count, huh? And then we go backwards and then in order traversal them. Count the frequency of each word as what we did in all previous approaches. Get a counter count. An initialized bucket of length n plus 1. N is the length of words with an empty trie in each bucket. That is, the trie in bucket I stores all words with frequency I. Enumerate words and count, and add each word to the trie, mapping to its frequency. I see, so at this point, you still do processing n time? I guess it's technically still n time. Huh. Is this actually n time? Okay. Enumerate all frequencies I in n from n to I, and then traverse every single bucket I within it with lexicographical order. Basically in order traversal, huh? For I in range, yeah, in order traversal. Dang. Though we optimize the time complexity to O of n, it may run slower than previous approaches due to the large constant factors. I see, but this solution makes sense to me. I don't know, is it really n time? Let's say the max character count, the max length of a word is like m time, let's say. So it's technically n times m time, right? Almost n squared time, kinda. I know I will like working on my project, but I can't seem to kick myself to actually start coding. Oh, I have that problem all the time. My solution was streaming. I'm not sure if you can do the same thing. I need peer pressure to do stuff I don't want to do. So, streaming is my solution. When I was smaller, it was like my mom sitting next to me while I did homework. In college, it was me sitting at the library while other people were around me. And then it would feel really awkward whenever I just started watching YouTube in the library and people were walking around me. And then now, since I'm not in college anymore, it's streaming. It's my best solution. Peer pressure. I don't know if you want to stream or... TC? What's TC? What do you mean by TC? TC... Total compensation? What do you mean total compensation? You don't use blind? Wait, what? I'm so confused. I don't use blind? Blind 75? What do you mean by blind? Teamblind.com? Teamblind.com. Which company? Oh, interesting. Salaries, huh? Oh, is this like Glassdoor where you look up your salary? Ooh. Interesting. It's basically career Reddit with verified work emails. Ooh. Wait, can you find people here? Usually? I don't know anybody on here. I've never heard anybody use this before. Also, excuse me, I need to blow my nose. It's anon? Oh, it's anonymous. But basically you don't get trash like CSCQ. I don't know what that is either. CSCQ? Because it's email verified. What's CSCQ? I mean oh, hold on. CSCQ. Ah, CS career questions. Really, I've seen posts from this subreddit before. Speaking of Reddit, have you guys seen the latest r/r drama? It's crazy. Oh, excuse me. Apparently this one mod he unnecessarily wiped the post history of one popular artist, and then he couldn't take the criticism and he quitted while making it seem like the entire mod team quitted, so he took everyone down with him. I don't know if r/art is still up. Art? Is r/art still up? Oh, it's still up. 4 days ago. Uh-oh. Are you not allowed to post now? No. You talked about peer pressure, so go back to work. Yes. Okay. Oh yeah, there's one last thing I wanted to do. I wanted to learn how the counter class worked. Python counter class. I've seen this being used in lots of Leetcode contests before. Counter. So you literally just wrap it in counter my list, huh? And then it'll be like apple 3, banana 3. That's so convenient. Just a one-liner. Print fruit counts. So does it act like a dictionary? Yeah, it does. Counter list of elements. So it's basically equivalent to a dictionary. I wonder if they can tell what is AI art now. I think it's getting so hard to tell. Like, in the past it was so easy to tell because AR wasn't there yet. You just had to look at the hands and see like, oh, 6 fingers, that hand looks weird. And now you have to look closer at the actual shading technique and stuff. Ooh, have you seen the post? Apparently One Punch Man Season 3, the latest episode, they were accused of using AI because like a bunch of inconsistencies, continuation errors. What do you call it? Continuity. One of the girl characters had like 6 fingers, and then one frame she had a band-aid on her head, and then one frame later it was not there anymore. It just flashed out of existence. And also some continuity with motion errors. So people were like, are they using AI? The 6 fingers thing is really suspicious. I've never seen an anime make that mistake before. One Punch Man, 6 fingers. Oh, never mind. People are debunking it right now. Do you guys think this is AI? Apparently it's been a mistake in some film map. I even did it. 1, 2, 3, 4, 5. Yes, image forensics can easily tell because on the pixel scale you can find JPG compression artifacts that are offset from how real artifacts will be created, or shouldn't be there at all if it's a PNG. It comes from facts. AI is trained on images regardless of the format. Oh, that's interesting. So you can look for weird So you can try to find AI trying to recreate JPEG compression artifacts, huh? I never heard of that. That's pretty cool. That's so funny to me. I don't know why management didn't catch it though, the manager's AI. That just looks fishy to me. Something just looks wrong. The hand looks way too wide. Yeah. And at one scene she had a band-aid on her face, and another frame just snapped out of existence and just got Thanos snapped in one frame. Alright. Well, we did... Alright. This problem is really interesting. Yeah. So apparently you could do a list of tries, huh? That's so wacky. Okay. Even if they use AI, why aren't they double checking? Yeah, you would think, because the art world right now is really sensitive against AI. I guess rightfully so. If you're using AI to take shortcuts, you should at least be like really careful about what images you put out, right? If you get caught using AI, it's a recipe to get cancelled. The internet hates AI. Okay, I think I'm gonna hop off for this stream now. We did 2 problems. We did one kind of hard problem, and then one relatively easy problem, I guess, so. It's been a while since we did like 2 problems in one sitting. Alright, I'm done for this stream. I think I might... Yeah, I should be doing the Leetcode contest tomorrow, I think. Most likely. No promises though, but most likely. Shashan Paige. Is that a Chinese name? Shashan Paige. Oh, thank you. Thanks everyone for coming. I'm gonna hop off now. See y'all next time or whenever I stream. I have no idea when. Bye. Bye, Toby. Bye. Bye, Shashan. Is that even how you pronounce your name? Is it actually like going down the mountain? It's Billy. Hi, Billy. Alright. Thanks, Billy.